Hey guys, welcome to another video. Today this is day 3 and chapter 3 of my Python learning experience. I hope you enjoy. This is just another disclaimer that this is not a tutorial series. This is a series of me documenting my own growth in learning Python. If you enjoyed, please leave a like and please comment. And if you really want to see more of this, please subscribe because I plan to do this every single day of January. So, yeah. Thanks for watching and have Hey guys, welcome back to another video. Today we're going to be diving into chapter 3 or day 3 of my month-long Python learning. So this chapter is called Python Elements and Syntax. And right at the get-go it's talking about the Zen of Python or something. I don't quite know what that means. Like, I know what the Zen of means, but whatever. Alright, so it says, open up VS Code, go to terminal, type in Python to activate Python, and then type import this. And then this pops up, The Zen of Python by Tim Peters. Okay, so I stuttered a bunch when I actually read this, so instead we're just gonna have Google read it for us.
Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one and preferably only one obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those.
Okay, so I don't know why. I guess it's kind of just like, this book just wants you to like know, I guess. And that's talking about PEPs, which stands for Python Enhancement Proposals. What a PEP 20 is. PEP 20 is just what we read. Zen of Python, because the 20 refers to the Zen of Python principles. Only 19 have been written down. Okay. Now it's talking about a thing called linting. And linting kind of helps out people learn, I guess. So it says file, and then preferences, and then settings. And this time I'm actually going to use the search feature. Workspace, settings.json. That's the wrong one, I think. Not what I meant to do. Alright, file, preferences, settings, settings.json. Alright. Alright, click workspace settings, and in the search box type in Pylint. Alright. Touch the mouse pointer to the python.linting.enabled, and if that option isn't enabled, click it and select true to enable linting. Real quick, I'm going to look at the diagram on here so that I can know what's happening. Alright. Python linting enabled. Okay, yes, so that's activated. And then we're looking for PEP 8. That's Flake 8. Flake 8. I think we're going to ignore that. I was talking about object-oriented programming. And that's like basically, all right, here it gives a really good example actually. Take a car, for example. Any one car is an object. Not all cars are exactly the same. Different cars have different properties such as make, model, year, color, size, and so forth that make them different from one another. And yet, they all serve the same basic purpose, to get us from point A to point B without having to walk or use some other mode of transportation. All cars have certain methods, things they can do, in common. We can drive them, steer them, speed them up, slow them down, control the inside temperature, and more using controls within the car that we can manipulate with our hands. Gosh, I'm having a stroke. An object in object-oriented programming language isn't a physical thing, like a car, because it exists only inside a computer. However, you can have a class which you can think of as an object creator, such as a car factory, that can produce many different kinds of objects, cars, for varying purposes. Sporty, off-road, sedan. All these objects can be controlled through the controls that all have in common. The controls that all have in common, much as the cars are controlled by steering wheels, brakes, accelerator, and gear shift. So like, there's like object-oriented programming languages, and there are other ones, of course. I like an example of an object-oriented is C#, I believe C++, and then Python is pretty object-oriented I'm pretty sure. But since we changed this, I'm gonna not press control. I'm just gonna save it. All right. So that's all like that. All right. So indentations count big time. So this is something else. We're gonna ignore that section. It's just a lot of talking. It's nothing really. All right, using Python modules. All right. All right, click on environment. That's Anaconda. We don't want to work with that. All right, actually, that looks like it's it, to be honest. That was a lot shorter than I thought it would be. But then again, I said I'm doing one chapter a day. So, yeah. Tomorrow is chapter 4, building your first Python application. So we're actually going to start coding instead of setting all this annoying stuff up. Okay, cool.